Welcome back, part 7 in the Leigh Dovetail jig series. Today we're looking at blind dovetails. That sounds good. Stick around. In the last episode we got to this point in the project. We'd made the through dovetails for the back of the drawer. We're now going to make the blind dovetails for the front of the drawer. The information for our variably spaced half blind dovetails starts on page 31 and is in chapter 10. As always, it talks us through, it tells us which part of the finger assembly we're going to use. It talks about rotating things and then how it all comes together. And as always, 1, 2, 3 and the job is done. But it's more complicated than that. And once again, there's quite a lot of theory that we need to go through before we can use the jig. This diagram here on page 32, once again, talks us through the terminology. The terminology is the same as the things we looked at last time. So we have the concept of the dovetails, and we have the concept of the pins with half pins either ends, and then the sockets that we spoke about. Where it gets a bit more complicated now is how you choose the router bit you're going to use. In half blind dovetails on the Leigh jig, your depth of cut is actually set by the cutting depth of the router bit. And here you can see there are 5 standard Leigh dovetail bits: the 128-8, the 120-8, the 112-8, the 101-8 and the 80-8. And you can see that they have different cutting depths depending on the bit that you're using. So for example, the 128-8 has a cutting depth of 19 millimeters. The 120-8 has a cutting depth of 11 millimeters. The 112-8 has a cutting depth of 13 millimeters. The 101-8 has a cutting depth of 16 millimeters, and the 80-8 has a cutting depth of 19 millimeters. It also talks about an overall board thickness and a minimum thickness for this front face. And if you just look at this diagram here in section 10.13, it's talking about that meat that sits ahead of the tail and the outside surface of our drawer. So that there has to be a minimum thickness. It tells us that that minimum thickness is 3.2 millimeters. It can be thicker than that, but any thinner than that you tend to have a weak joint and a chance of that front edge blowing out. So they're recommending 3.2 millimeter thickness. So if you therefore look at this, if I've got a cutting depth here of 19 millimeters plus an overall thickness at the front of a minimum of 3.2 millimeters, then this here is going to be good for 22.3 millimeter stock. If this has got an overall cutting distance of 16 millimeters plus a thickness of 3.2, then that's going to be 19.2 thickness of stock. If this one has a cutting depth of 13 millimeters and a thickness of 3.2, that must be 16.2 millimeter stock. If this one has 11 millimeters plus the 3.2, 14.2. And this has got a 9 millimeter plus the 3.2 at the front, then that's obviously going to be 12.2. So you can see that the combination of that thickness at the front and the cutting depth of your bit dictates the stock that you should be using. Now if I want to use 18 millimeter stock, then this is no good for me because the minimum thickness I want is 22.3 millimeters. 19.2 is also greater than 18 millimeters, but 16.2 looks good. So we're going to choose the 112-8 router bit for this job. Now once again, in the appendix at the back, appendix 2 page 75, there's more information about the half blind dovetails. And here there are tables again that look very similar to the through dovetail tables we looked at last time. This is now giving you that same information. So an 80.8 cutting depth of 19 millimeters. A 101.8, 15.9 and so on and so forth. So there's a bit more information provided there, and what's interesting is the dimensions that are given here are different than the ones that are given here. An 80.8 is 19 millimeters check. a 101.8 is 16mm here and 15.9mm here. The 112.8 is 12.7mm and 13mm here. The 120.8 is 11mm here and 11mm here, and the 128.8 is 9mm here and 9.5mm here. So there's a slight variance and contradiction in the manual about the cutting depths of those router bits. And just to make matters even more confusing, if you go to the end of the blind dovetail section, on page 38 there's a quick reference reminders piece, which is useful, I think, to a point, and on there's a table that's summarising the information. The problem is this is different information again. So we've got the first section that talks about the cutting depth and the allowable thickness of the front edge. We've got the back section that gives us different cutting depth to those router bits, and this gives us a different information again. So this is my saying my thickness of my pin board is 22mm with a cutting depth of 19. Well, 22 minus 19 is 3mm, so that's smaller than the 3.2mm we're talking about. This one's saying 16 depth of cut, thickness of board of 20, that's now 4mm. That's okay, that's greater than 3.2. This is giving me a thickness of board of 16mm with a cutting depth of 13mm, again 3mm less than the 3.2. And this is giving me a 14mm, 11mm, 3mm again, and this is giving me a 12mm and a 9mm, 3mm again. Now what's happening here, I think this is to do with the conversion between imperial and metric. I think the manuals and the sizing are all based on imperial and then translated and converted into metric, and that's why we end up with variances across the manual itself. So it's a little bit confusing, but it also tells me that it doesn't really matter. So near enough is good enough, and we do tune the joint towards the end. So what am I going to do here? I'm going to use common sense, and I'm going to stick with my original choice of 112.8, and the reason is I will cut this down to the recommended cutting depth of 13mm, and I know I'm using 18mm stock, so that's going to give me a 5mm front profile on my joint. That's going to mean this thickness here on my joint is going to be round about 5mm, and I think that will look quite good set against the thickness of the stock. So I'm using common sense, and as long as I'm not going to end up with this front edge too thin, i.e. 1 or 2mm, which to me is way too thin and not strong enough, I'm in good shape. 18mm stock with a 13mm cut, 5mm profile on the front, landing me on a 112.8 router bit. So it's worth just thinking that through a little bit, and the manual is contradictory when you bring all that information together. So there's my bit of choice, 112.8. Good. Now the next thing the manual talks about is how you tighten and loosen the joint. Once you have selected your bit, you use this to cut your tails and your pins. So for this one, we're not using the straight cut bit as we did in the through dovetails. This is the one and only bit that we are going to use. And the thing that makes your joints tighter or looser is the depth of cut that you put on this. So you start off with that recommended depth of cut, 13mm. In our case, and if you want to tighten the joint, you raise this, so you've got a shallower depth of cut. If you want to loosen the joint, you lower this, so you've got a greater depth of cut, and then that loosens the joint. And these sections 10.3, 10.4 and 10.5 explain why that's the case. Now obviously this is a router bit, and a router bit has exaggerated a wedge shape profile, and you're going to pass that through a piece of material to cut your joint. So if you lower this down into your wood, the narrower part of your dovetail is exposed, therefore it cuts less off these remaining pins. If you raise this, the wider part of the dovetail is exposed on the cut, therefore you cut more off these pins. That's it. So you're altering the width of those pins by the part of the dovetail bit that you expose to the top of your material. Makes sense to me. So now we understand what we're doing, it's time to turn to the jig. Now the first thing to note is you are not going to go directly into your stock for your project and mess around with the cuts. Remember, on the through dovetails we actually cut the dovetails first and then we use scrap stock to size that on the pins. We're not doing that here, we're going to come straight in with some scrap stock. And that's because there's a lot of trial and error on the creation of these blind dovetails on the Leigh jig. Scrap stock. 18mm squared all round, and I've just made this to the same width as the stock we're going to use on the final project. And we're now looking for this symbol here on the finger assembly. It's the green scale and it looks like, well, a half blind dovetail, and that's going to go onto the right hand side. We're going to set a distance against the marks on our jig of the thickness of the tailboard. And in our case that's 18mm. Now remember, one of the great things about a blind dovetail is that your pin boards and your tail boards can be different thicknesses. So if you've got a variance, you might be deciding to go for a 20mm pin board to give you a thicker profile at the front and an 18mm side panel, and it's not unusual to have that configuration in draw assembly. You're still going to set the jig for the tail board thickness. In our case that's 18mm. Then take a scrap piece of stock, you can see what I had to practice here, and you mark it up with your face edge as always. For blind dovetails, your face is now going to be facing away from you. You should have a mark on the back of your piece of wood that says I'm an inside face. That's what needs to be facing towards you. You also need to remember the depth of cut that we spoke about. So we know we're using this router bit and the depth of cut is 13mm. And on the ends of your stock, just give yourself a 13mm mark, which is going to be there. Make sure your fingers are flat and firm to your backer board and lock that down. And then you can clamp your front piece of stock in underneath those fingers and just clamp it into position. And now bring your backer board up and clamp that into position. Next job is we need to set the position of these fingers. Now if you look up the makeup of this joint, you still have a half pin at either end of the joint, and these are the tails that then slot into your sockets. So when we lay this up, we need to allow for that half pin. But remember, this is a tail board and we're in the tail configuration, so you've got to eye that up. So if you bring this all the way over and line it to the edge of the board, there's nowhere for that half pin to sit. So you need to, by eye, take that in. Now this is going to route out in that direction, so that would be my tail if I was to put that there. So therefore that distance would be the half pin. So that doesn't look actually too bad. So I'm going to set those two fingers there for the time being. And then bring another set of fingers in and give myself a similar distance on this side, probably something like that, and then that would be the overall configuration of the joint. Now there's no real set distance for this one, so it is one of those things you've got to use your imagination and eye it up. For reference, I've set this first finger in about 6 to 7mm, and that's probably going to look okay, I think. Again, that's trial and error. Lock the two outside fingers down . And now you've got some choices in the middle. You can make all these symmetrical, so it would be like that. I could open these up a little bit, so that middle dovetail will be slightly wider than the two outside ones. I could offset them slightly if I wished, or I could make the two outside ones slightly wider than the middle one. I think I'm going to do that and make the middle one slightly wider than the two outside ones. So then you can lock all those down, and that gives you the final design for your dovetails. Now if this gap on your fingers was excessively wide, you could come in with a small piece of bridging material and slide it into the end of the fingers. That's not going to be a problem. The bush won't go down that slot, so I'm not worried about it in this configuration. So that's pretty much it. Next job is to set the depth of cut on your router. Remember, we made a mark 13mm down on our tailboard. So now it's simply a matter of lining up the bottom cut of your router bit with that mark. And you just do that by plunging down, like so. I'm also going to zero that, so I've got a reference point. I'm just going to use the depth scale on the side of my router and just give me a mark of 13mm, which is there. And that'll just make it easier for me to adjust this depth of cut. And remember, it's a depth of cut that makes a joint tighter or looser. So if you do have an incremental adjuster like we do on the Festool, that's going to allow us to dial in a level of accuracy. If not, you can always rely on the plunge or whatever mechanism your router has. The routing technique, I'm going to come into this edge here first, and I'm going to do a climb cut across here to establish the shoulder, and then I'm going to run the bush around the profile of my fingers to complete the joint. And then what you end up with are your tails, and you can see this is the side that's going to be the outside face, so these are the tails that are going to show, and you can see this profile here, this nice shoulder line internally from that climb cut, and this rather unique profile that you get from your cuts. You can also see I've got a nice shoulder gap here between the ends, and that's where the half pin is going to go. And if you look at the mistake I made on my practice cut, I put these pins too far to the outside. This finger here was too far over, and therefore there's nowhere for a half pin to go, and that's why that cut was wrong, and that's what we're going to go for. But that's why we use test pieces and practice before we commit to the main workpiece, of course. So this is looking good. Let's get on to the next step. So it's now the turn of the pin board. We route pin boards on top of the jig. So we'll take out our backing board, and I'm just going to bring the backing board up on this side here and just hold it lower than those fingers by about 3mm. I don't want this to interfere with the cut that we're going to make in this direction, so we'll just drop that down out of the way, but I do want this as a reference point for my pin board when it comes in. So that's the sort of configuration that we are going for. Now again, we're going to be working from the inside edge, so the face wants to be down. You should have that symbol facing upwards, and that simply slots in to the jig, referencing on the outside arms, coming up to reference on the front of your scrap piece of material at the front. That's now aligned perfectly. We're now going to turn this over so we can cut the sockets, and we set it to exactly that same depth that we did earlier on. So 18mm is there, and 18mm is there. Make sure that our pins are flat on the board, like so. Now it's a matter of routing out this waste in between. We're working on end grain, so please do not do any climb cutting on the end grain. It won't work out very well for you. And you want to be cutting from left to right. Now this is quite a lot of material to take out, so what you want to do is to take it as a series of passes. Come in, pass, come in, pass, come in and pass until you hit the back of these fingers. So probably 3 passes going from left to right to give me this profile. The same router bit at the same depth, don't change anything. Let's go ahead and make that cut. And now you can clearly see the half pins that we left and the dovetail sockets inside here. Now note here, this was the cut that I lined up initially, and the clamping force on this wasn't sufficient and the router twisted it, and you can see it blew out the joint. So lesson learned, really make sure this is clamping down firmly onto your material. And now it's a case of testing the joint. And basically everything is wrong here. This joint is too loose, and I know it's too loose because I have this gap here at the base of my fingers. and I'm also not deep enough, and this is way too proud. We're going to correct one problem at a time. So the first thing I want to do is to route this a little bit deeper. That means I need to lower the depth of cut inside my router by whatever that distance there is, and that distance is going to be 0.1 of a millimeter. I can now use my incremental adjuster on my router to dial in that 0.1 of a millimeter. And now I need to make another test cut, so I'll clean up the material and we'll have another go. So we now have a joint that's beginning to look something like, so that 0.1 of a millimeter variance has really left a nice joint. It's now too high this way, so we now need to allow for the depth of cut, but in terms of the tightness of the cut, that's absolutely bang on. So therefore we need to alter the depth of cut of these sockets, and remember, this is the pin board that we routed on top, and that's consistent all the way down, so in theory I can just route these a bit deeper and get the right setting. So put my pin board back in, I'm in the right place, my sockets are showing, and I need it to be slightly deeper. So I'm currently set at 18 millimeters on this gauge, so I'm going to move this to 19 millimeters, which is there, and which is there, and we'll retry it. Just notice I'm just resting a piece of the stock the same thickness underneath his fingers just to stop this twisting, because it's quite a narrow board. And that's a lot closer. You can start to see the joint coming together now, but it's still ever so slightly high for my liking. So I'm going to take it down probably about 0.1 of a millimeter. So I'm going to take this down to 19.5, and that's come out perfect. So that's good. We're happy with that. So we've got the settings. Joints tight enough. Lines are all nice inside, and it's level enough. Obviously that's just an old knot that's torn out, so I don't care, it's only a test piece. So we're going to call that good. So coming back to my drawer assembly, this is my front, and this is the piece I want to put the sockets in. This is the pin board, if you remember. So while my jig's set up for those sockets, I'm going to cut the sockets into this board. Okay, we're now going to come in and do the tails, so rotate this, and remember this is set to 18 millimeters, even though we've altered the other end. Make sure everything's clamped down. Lower the fingers into position, make sure everything's nice and flat. So there we have it. We have a front piece, we have a rear piece, and we have a couple of sides. So let's see whether this has actually worked. It goes together nice and sweetly. So there we go, we have a box. Joints aren't too bad, they'll clamp up quite nicely I think actually. So yeah, pretty good. We've ended up with a box that is square. And fits nicely into the place where it's going to live. So I made a drawer front and a door whilst off camera, so I just need to fit those in there now, and that's going to look pretty good. And that's how you do blind dovetails on the Leigh jig. I'm going to go and put the base in this. I'll glue it up, and then next time we're together I want to do a comparison of my thoughts of the Leigh jig and the Incra system. So if you've forgotten what we did on the Incra system, it might be worthwhile just going back and checking out that playlist. And we'll do a summary, we'll look at the final products both from the Leigh and from the Incra in that episode, and we'll make a decision. If I was to buy only one, which one would it be? Thanks for watching as always. I hope you're finding this useful. I will see you next time.